Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, episode 17. And we're going to be looking at combining transformations. This will be a very, very short episode. And we'll just give a very quick example, basically. So in gaming and 3D rendering, let's suppose you have an object and it has its own position and orientation in the world. We want to render it given a camera, in its own position and orientation. We're going to transform the object vertices and transform from object to world space and from world space to camera space. So what does this look like? Well, the position in the world is going to be position the object times the matrix of the object within the world. So that's the first transformation. And then we're going to have the position to camera, and that's going to have its own position in the world with a matrix of transformation from the world to the camera space. So you could substitute the first equation up here into the second equation, which gives you this third equation where the position of the camera is the position of the object with the transformation from object to world space and the world space to camera space. Well, matrices are associative for multiplication, so we can move these parentheses over and you end up with this equation here. So you have these two, and you could also see that you can concatenate matrices. So this object to world space and world to camera space can be shortened from object to camera space. So finally, we end up with this position of the camera is the position of the object to the transformation of object to the camera space. So what's happening here with this concatenation? Well, remember that the rows of a matrix contain the basis vectors after transformation, even after multiple transformations. So even after there's multiple transformations happening. So what does this look like mathematically? So you have three different A1, A2, and A3 are the rows of A. And so this is a matrix with the rows. And so AB is this matrix here times B. And so when you're concatenating, all you're doing is you're going to have A of 1 times the matrix B, A of 2 times the matrix B, and A of 3 times the matrix B, with each of those being representative rows. That's basically it. So nice and short and easy. You can see how we can combine multiple matrices easily and get to a faster set of equations, and then you don't have to do as much math ultimately, which is good, and it'll save us time. So we'll keep it nice and short for this episode, and we'll get to the next episode shortly. If you like what you saw today, give it a thumbs up and a like, share it on social media, and go to ProgrammingTIL.com and sign up for my newsletter. Have a great one. Thanks.